So good morning, good afternoon, everyone. Why I'm saying morning? Good afternoon, everyone, and welcome to the lecture. This is lecture number 13 in capacitance, and we are dealing with dielectrics. In the last class, we had started with the dielectrics concept, and we were able to cover some part of it. Good afternoon, Jagdish. I hope you remember what we had done in dielectrics. We had seen the effect of dielectric when the dielectric is completely filling up the space between the capacitor plates, and we had seen that in that condition, the dielectric constant K gets multiplied with the original capacitance, and the new capacitance becomes K times the original capacitance. Do we remember this? Yes or no? Do we remember this? Yes or no? Okay. We had also seen that this process can happen in two separate ways. In one way, the battery remains connected, and in the other one, the battery remains connected. And we had seen a couple of examples as well of this battery remaining connected and when this battery remaining intact. Do we remember this? Yes or no? We remember this. Everyone remembers this. Now let me give you a question based on this so that it refreshes our memory. I also told you that if nothing is mentioned, whether the battery is connected or whether the battery is disconnected, you will always assume that the battery is disconnected. Yes or no? Do we remember this? That if it is not mentioned whether the battery is connected or not, you will always assume that the battery is disconnected. So on that note, I will bring you this question and I'll give you 2 minutes to solve this question. A capacitor when filled with a dielectric constant K equal to 3. Question number 1. It has charge Q naught, voltage V naught and electric field E naught. If the dielectric is replaced with another one having dielectric constant as 9, what is the new value of charge, voltage and electric field? I'll give you 2 minutes to do this. So then how are we supposed to do this? As nothing has been mentioned here, so I will assume that the battery is disconnected. So I'll solve this question assuming that the battery is removed or the battery is disconnected. Battery is removed or the battery is disconnected. Now once the battery is removed or the battery is disconnected, the charge Q will remain same. So Q naught, it is same here, it is same here, and it is same here. But as you can see, option number C is absolutely wrong because if potential difference becomes V naught by 3, electric field cannot become 3 times C. So that is wrong. So you just have to find out whether the voltage has become 3 times or voltage has become 1 by 3. The voltage becomes 1 by K times. So the original voltage was V naught by 3. The new voltage now becomes V naught by 9. So in terms of V naught, it becomes V naught by 3. And therefore, the correct option has to be option D. Do we understand this? Or shall I solve it and do it for you? Everyone understands this?
Sir, solve it, sir.
What you don't understand? What you don't understand? Tell me. Please tell me what you don't understand. Tell me what you don't understand, bacha. Tell me.
I understood the calculation, sir.
Not understood the calculation, sir. Okay. I mean, what is there to understand here? Anyways, I can take this capacitor. What do I make you understand? I have to divide things and make you understand. Okay, I'll do that. So, how do I start? I start like this. The original capacitance, the original charge, if I call it as Q naught, if I call the original charge as Q naught, the original voltage will be 3 times V naught and original electric field will be 3 times E naught. When I fill in with a dielectric constant 3, the new values become Q naught, V naught, and E naught because the voltage gets divided by 3. Now, when I put in a dielectric constant 9, it will become how much? From the original value, it will become 1 by 9 times. So from the new value, it will become 3 V naught by 9. 3 V naught by 9 is V naught by 3. And this will become E naught by 3. This is your original capacitor. This is the capacitor in which K is equal to 3 ka slab. No, sorry, what I have done. I have also written ulta. This is your original capacitor. This is the capacitor in which the dielectric constant 3 has been inserted. This is the capacitor in which a dielectric constant 9 has been inserted. So that is how it is done. I hope we are clear with this. Yes or no? You just have to divide it, nothing else. Okay. Now, that was the case when a dielectric constant K was inserted and it was completely filling up the space between the two plates. Now, I'm going to do the next case, and in the next case, what I'm going to do is insert the capacitor with a dielectric, but it is not completely filling up the space. So that is my section B, not completely filling. The dielectric is not completely filling up the space. Now, in this not completely filling, we can have two types of configuration. Let me start with the first type. So not completely filling. So what will I have? Case number 1, I will have this capacitor plate and I will have a dielectric which is kept like this. The thickness of this plate is D and the dielectric constant is K. So now what I have done is I have not completely filled it up with a dielectric, but I have partly filled it up with a dielectric constant K. Now remember, my original area of this capacitor plate is A and the distance between the plates is D. Now, in this case, what is the capacitance going to be? We are not going to get into much details of that. There is no point of getting into much details. I will just write the capacitance here. The original capacitance you must understand was epsilon naught A by K. Epsilon naught A by K. The new capacitance in this case becomes epsilon naught A upon D minus T plus T by K. It changes like this. If I find out the ratio between the two capacitance C dash by C, C dash by C will be how much? C dash by C will be how much? It will be D minus T plus T by K divided by D. The new capacitance would be this much. And this is what you have to remember. This is what you have to remember. The new capacitance can be written like this. What are the things that you have to remember about this? First thing, C dash will always be greater than C. That means the capacitance has to
Sir,
increase. Yes, beta? Any doubt? I think I have written here K, I should have written D.
yes, sir.
Okay, thanks for correction. Capacitance is always increased. Capacitance does not decrease, it always increases. Second thing that you must remember is C dash, the new capacitance, does
Sir,
not depend on, yes.
sir,
Oh, I've written it.
the equation will
I have
be
written the equation in the reverse order.
yes, sir.
So I will write it in the correct order. C by C dash. Now it is correct.
Yes, sir.
I have written it in the opposite sense. Yes. Okay. So capacitance C dash always increases and C dash does not depend on the position of the slab. Wherever you place the slab, it does not depend on the position of the slab. So these are the two things that you must remember, and I'll give you 2 minutes to note it down. Note it down, understand it, write the ratio in the reverse order, write it as C dash by C, not as C by C dash. So it will be D upon that thing. Okay. Okay then. Now see, in this case, this becomes a general formula. If your value of T, and if I can just write it here, if your value of T becomes equal to D, this formula will come back to the original formula. C dash will become K times C. So if you remember this formula, you don't have to remember the formula where the entire dielectric was filling up the space, because this formula comes from here only. Now there could be a second case where not one, but more than one dielectrics could be there with different dielectric constants and definitely different thicknesses. So that is your case number 2. Let me take that case as well. As you can see, there are a number of dielectrics here with different thicknesses and different dielectric constants. If I just write here the original value of capacitance, that will be equal to epsilon naught A by D. Can anyone tell me what will be the value of C dash? When I say C dash, I mean the new capacitance with all these dielectrics already there. Yes. No idea?
Epsilon naught A
Epsilon
epsilon
naught
A
A.
by D minus T1 minus T2 into T1 by K1 plus T2 by K2.
So it will be summation of Ti. So D minus summation of Ti plus summation of Ti by Ki. Do we understand this?
Yes, sir.
Now, if I write the ratio of C dash by C, and I hope that I write it correctly this time, this will be D upon D minus summation of Ti plus summation of Ti by Ki. Anyone understands this? Yes or no? और this has gone above our head saying bye bye sir, निकल गया ये तो ऊपर से bouncer हो गया.
Understood, sir.
I'll give you 1 minute to note it down. Draw the diagram on your own and then note it down on your own rather than copying it from the board. Take it as a question that this is a question. Okay, 2 minutes you have. Okay, then let's move ahead and let me take you to the next case. And in next case, what I am going to do, nothing special. I'm just putting the next case in this fashion where there is no space left in the capacitor and these dielectrics are actually completely filling up the space. I have shown it with 4 dielectrics, but there could be, I cannot draw infinite dielectrics in this diagram, so it is given like this. Now in this case, what is going to happen? You can see there is no empty space. Your original capacitance always remains epsilon naught A by D. Your new capacitance C dash becomes epsilon naught A upon what? D minus T is 0, so it simply becomes summation of Ti by Ki. Do we understand this? Do we understand this, everyone? So in this case, if I write the capacitance C dash by C, C dash by C will be turning out in this fashion, summation of Ti by Ki. That will be your effective capacitance in this case. Do we understand this? Yes or no?
Yes, sir.
Anyone understands this? Now, I have given you the direct formula of calculating capacitance in all these cases, but actually these capacitance could have been found out in a different way. Can anyone tell me what could be that different way? In all these cases, I have given you the direct formula, but all these cases could have been done using the concept that we have already studied. How could I have done this? Now remember, all these questions could have been done by the concept of series parallel combination. I could consider, let us say in this case, I could consider this capacitor as C1, this capacitor as C2, this capacitor as C3, this capacitor as C4, and so on. And then you would have realized that all these capacitors are connected in what fashion? They are connected in
Add
between this point A and this point B. How are these capacitors connected?
series.
Series, sir.
They are connected in series. You could have found out the value of C1. Let me just write the value of C1 here. C1 will be equal to K1 into epsilon naught A divided by T1. Do you understand how I got this value? Do you understand how I got this value?
Yes, sir.
Similarly, your C2 would have been K2 by T2 into epsilon naught A. And similarly, you could have found out the value of individual capacitance, and your 1 by C equivalent will be equal to summation of 1 by Ci. You do it in this way, or you straight away use the formula. Both the results are absolutely similar. Do we understand this? Yes or no? So instead of doing it in this way, I could have done this in this particular way. We understand this, everyone? Okay. Now, this is one way of filling the capacitor, but obviously this is not the only way of filling up the capacitor. This way of filling the capacitor, if I go back and write, this way of filling the capacitor is known as distance division. I can call it distance division. Why I'm calling distance division? Because these dielectric slabs are having the of same area as the area of the capacitor plates, but they are having different distances, different thickness, and they are dividing the distance between the capacitor plates. Do we understand this? Yes or no? Do we understand this?
Yes, sir.
Now, instead of these dielectrics dividing the area, dividing the distance, they could have divided the area division. They could have divided the area. What do I mean by area division? These are the plates of the capacitor, and now I completely fill it up. Okay. Now I completely fill it up, let us say, with two dielectrics in this fashion. The blue dielectric has dielectric constant K1 and area A1. The green dielectric has dielectric constant K2 and area A2. So I fill it up like this. This type of filling would be known as division in area. Do we understand this, bacha? This type of division could be known as division of area. Now, the original capacitance, still remains epsilon naught A by D. Epsilon naught A by D. Can you tell me what will be the new capacitance in this case? I will give you 2 minutes to tell me the answer. I could hardly hear anything, but I hope you understand. If you call this capacitor as C1, if you call these capacitor as C2, these two capacitance are connected in parallel. Yes or no? So your equivalent capacitance will simply come as C1 plus C2, C1 plus C2, and your C equivalent or C dash, the new C dash will come very simply epsilon naught by D into K1 A1 plus K2 A2. Yes or no? No, yes. You can straight away write your, you can straight away write the ratio of C dash by C will be equal to how much? K1 A1 plus K2 A2 divided by A, and that would be your answer in this case. This is known as the area division of capacitance. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Okay, this is area and distance division, but there is one more thing that can be done, and we will move ahead and do that before moving on to problems. Next case is inserting metallic slab between the capacitor plates. Now, instead of inserting a dielectric, you may insert a metallic slab. You may insert a metallic slab, slab of a metal, slab of a metal you can insert. Now you can insert it in different ways. Let us take a look at the first case. In case number one, what I have done is I have inserted a plate, a slab of metal whose thickness is T. Now in this case, if I call the original capacitance as C epsilon naught A by D, what would be the new capacitance C dash coming as? This is case number one. Yes?
Similar to A by
Answer
D
would be
minus T.
epsilon naught A upon D minus T. Yes or no?
Yes, sir.
You can also find the ratio. You can also find the
By
ratio.
C dash equal to D minus T by D.
D by D minus T. So here also capacitance has increased. This is case number one. Do we understand this case? Yes or no? Now there could be, everyone has noted down this case?
No, sir.
Okay, I'll give you 2 minutes to note down the case. Once you are done, then please let me know. Well, then that takes us to case number two. If you have a capacitor which is completely filled up with a metallic plate, you insert a metallic slab and it completely fills up this space. In that case, what will happen? Your capacitance will turn towards infinity, and you can call it as a infinite capacitance if you want to. Now the same thing will happen if instead of inserting the slab I just connect the two capacitors together by a plate, and this thing together by a wire. So here I have connected the two plates of a capacitance by a wire, and I told you we have done this in series parallel combination. Whenever two plates of a wire of a capacitor are connected to each other by a wire, you can take the 2 point as same and no charge will be coming because the capacitance becomes infinite. Did I tell you that or not? The potential becomes zero. Yes or no? So in this case also the capacitance will become almost infinite. Do we understand this? Both the cases? Yes sir or no sir? Not getting any replies. Do we understand this case? Yes or
Sir.
no?
Yes, sir.
Pakka sir?
Pakka, sir.
Okay. Have you noted this down everyone?
Noting, sir.
Okay, I'll give you 2 minutes to note it down and then we will move ahead. So let's move ahead. We have understood this and let us now solve some questions based on this. So this is the first question that is coming for you. It is a previous question from IIT. It has been repeated several times in several exams. So we are looking to solve it. A slab of copper of thickness B is inserted between the plates of a parallel plate capacitor as shown in the figure. The separation between the plates is D. If the value of B is D by 2, then the ratio of capacities of the capacitor after and before the insertion of the plate. What is the ratio of capacitance C dash afterwards divided by capacitance C before inserting the plate? What is the answer? Do we have any answers for this? Yes, I'm waiting.
Option B, sir.
Option B, sir. How did we get the answer, sir? Option B is correct, sir. How did we get the answer, sir?
C dash by C equals to D by
You just can
D
use
minus
that
T.
thing that I've gone. C dash by C will be
Yes,
equal
sir.
to D minus D by T, and T here is D by 2. So you just put the values and you will end up with the answer. Do we understand this? Yes or no?
Yes, sir.
Okay. Shall we move ahead with the next question?
Yes, sir.
This is the next question coming for you. Where is that? Yes, beta. So this is the next question for you. A parallel capacity of a parallel plate capacitor is C naught. If a dielectric of relative permittivity, that means K, epsilon R, and thickness equal to 1/4 of the plate separation is placed between the plates, then its capacitance becomes C. What is the ratio of C by C naught? What is the ratio of C by C naught? Anyone with an answer? Okay, I'll give you 2 minutes. So we have an answer, and the answer is
B, sir.
option B. It's taken so much of time, but I think the answer is correct. How do I get it? I can just simply apply the formula and get away with this. Original by new by original will be equal to d upon d minus t plus t by k. You just have to put the values in this and you end up with the answer. And the answer I think will be 4 times k. Epsilon naught is will get cancelled. 4 times k upon 3 times k plus 1. That is the answer that you must get. Everyone got this? Yes or no? Pakka? No doubt on this? I can move ahead with the next question. Yes or no? So I'll put this question for you. And I hope that you are able to do this. It's a simple question. Just to make things simple, I will call this area A1 as A by 2. Area A2 is also A by 2. This distance is D by 2. This distance is D by 2. Your K1 is K. This is your 2K. And this is your 3K. Do you understand the question now? Do you understand the question?
Sir.
A by 2 is filled up with a dielectric of dielectric constant K. Then one half of the A2 is filled with 2K. The other half of A2 is filled with 3K. You have to tell me the effective capacitance in this case, and I'll give you 2 minutes to do that. Let me know once you are done. So let us go on and solve this. If I call this capacitor as C1, what is the capacitance of this capacitor? Can anyone tell me? If I call this capacitor as C1, what is the capacitance of this capacitor?
Eleven K epsilon naught by 10D.
If I call this capacitor as C1, what is the capacitance of this capacitor?
Epsilon naught A by D, sir.
K. Oops, why I'm writing A? K epsilon naught A by 2D. That is correct. Good. If I call this capacitor as C2, what is the capacitance of this capacitor?
It's K epsilon naught A by 5D.
I don't think so. 2 into K, area is A by 2 and distance is D by 2. So yes, I think you will get that. 2K A by D. Did you say this? Okay, sorry. Let us find the capacitance C3 of this one. What is the capacitance of this one?
3K by D.
So 3K A by D. A by 2 and D by 2 half will cancel. Now this C2 and C3 capacitors, they are connected in series. Yes or no? So your C2 and C3 are in series. So you can tell me the effective capacitance. What will be the equivalent
6K
capacitance for 3?
150.
Don't worry about that K, but just look at 3 and 2. So 3 into 2 divided by 3 plus 2. So this will be equal to 6 by 5 Ka by D. Do we understand this?
Yes, sir.
Yes or no? Now this one and C1 are in parallel. Do we understand this? So the final equivalent capacitance would be 11 by 10 Ka by D, and that is our final answer. Do we understand this? Or this has gone above what it's saying bye bye, sir. I'm going, sir. Bye bye, sir. Bye bye. Do we
Sir, where
understand
is epsilon
this?
naught?
Everyone
Sir,
understands this?
sir,
Ah, yes.
where is epsilon naught?
Oh, I forgot epsilon naught. Our old friend epsilon naught. Our old friend epsilon naught. Now it comes back. K 11 Ka epsilon naught by 10D. That is the answer. Do we get this? Yes or no?
Yes, sir.
Okay. So I hope you have understood the concept of how to find out this. Any question that comes? Yes or no? So here is the next one. Can you give me the answer for this one? This is question number 4, I think, or 5. I don't know. Let's have the answer for this one. I will give you 2 minutes to give me the answer. So, anyone got any answer?
Option C, sir.
Option C, sir, and that is correct, sir. You can straight away use the formula that we had created. C dash by C is K1A1 plus K2A2 divided by total area A. One of them is vacuum. Its dielectric constant is 1. So that is A plus one of them, A by 2 because half is the area, plus the other one has dielectric constant K, area is A by 2 divided by A, you will get 1 plus K multiplied by 1 by 2 and you multiply it by C, your C dash becomes C by 2 into 1 plus K. Do we understand this? Yes or no? Yes or no? Do we understand this? Anyone understands this? Okay, shall we move ahead? Now, before moving
Yes,
ahead,
sir.
I will just do one last part of the theory that is remaining, and we'll just do that, and then we will move on to questions on this type. So let us write the next heading, and the next heading is going to be force between the plates of a capacitor. Force between the plates of a capacitor. Now, what do you mean by this? What do you mean by this? It's very simple. It's very simple. You have a capacitor. One of the plates is positively charged, let us say plus Q. One of the plates is negatively charged, let us say minus Q. Now these plates have charge. And whenever there are two charges, they will experience forces on each other. Yes or no? They will exert
Sir.
forces on each other. Yes or no?
Yes, sir.
In this case, whether the force is going to be attractive or whether it is going to be repulsive.
Attractive.
Attractive. So this plate will be attracted this side, whereas Negative plate would be attracted this side. Yes or no?
Yes, sir.
Will the forces acting on these two plates be same in magnitude or different in magnitude?
Same in magnitude, sir.
It will be same in magnitude because this force forms an action reaction pair. So it would be same in magnitude. We're not going to get into the derivation part of it. That is irrelevant. Remember, it is given by this q square by 2 times A epsilon naught. This is the force of attraction between two plates of a capacitor which have a charge q. Now you can write it in terms of the charge q. You can write it in terms of the charge q, or you can also write this in terms of the surface charge density. So in that case, it will look like this. So I will give you both the results. You can write it in whatever way you feel comfortable. You can write in the way of in terms of charge, or you can also write it in terms of the surface charge density. This is the force of attraction between the plates of a capacitor. Do we understand this? Yes or no?
Sir.
I'll give you 2 minutes to note this down. Well, one more thing, it is normally done here, but I have already given you that formula, but again, I will give you here energy density. Energy density of an electric field, or energy density between the capacitor plates. No matter wherever there is electric field, there is energy stored in that electric field, du by dv. Do we remember this energy stored per unit volume in an electric field? Anyone remembers it? What was the formula of energy stored per unit volume, energy density? The formula was half epsilon naught E square. And I think we had done a couple of problems on this as well, including the problem from S.C. Verma. You seem to have missed it. Not to worry. So I can find out the small energy stored in any space, half epsilon naught E square multiplied by dV. That gives me the total energy stored in any space will be the integral of half epsilon naught E square into dV. I'm giving you this formula. I had full faith that you would have forgotten the previous formula that I had given. I knew that. So it's my duty, since I could give this formula once again. I had the time, so I have given you this formula once again. I don't know if I can tell you this formula third time around. Anyways, this is the formula of energy density, and from there you can find out the energy stored in any electric field in a given volume. Everyone understands this?
Yes, sir.
Okay. I hope you have written this formula once again. Now, this is the question, this is the type of question now that we will do so that this concept becomes clear. This is the first question in line. An air capacitor. When someone says air capacitor, he means a capacitor which is filled with air. An air capacitor of capacitance 10 microfarad is connected to a constant battery of voltage 12 volt. So the battery is connected in this case. Now the space between the plates is filled with a liquid of dielectric constant 5. Find the charge that flows from the battery to the capacitor. I'll give you 2 minutes to give me the answer. So now I give to you this question. This is taken from your book. If you have the book, it's question number 52 unsolved. I don't know the page number. A capacitor stores 50 microcoulomb of charge when connected across a battery. When the gap between the plates is filled with a dielectric, a charge of 100 microcoulomb flows through the battery. What is the dielectric constant of the capacitor? And I'll give you 2 minutes to do it. Yes, the dielectric constant is definitely 3. And how do we get this answer? This is actually the reverse question of the question that we have already done. Yes or no?
Yes, sir.
When the dielectric is inserted, 100 microcoulomb of charge has flown. So the total charge, the new total charge, Q dash, becomes 150 microcoulomb. Yes or no?
Yes,
And the
sir.
total charge Q dash, the new charge Q dash must be K times the original charge. So the K, the value of K becomes 3. And this is how questions are put in the examination hall. Do we understand how this question was done? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now let me give you another one. And again, I'm trying to find a question where you don't get stuck in the calculation part. So this is a question that I found out. Again, it is the next question in the category. Call it question number 6. I will read out the question and then I will give you 2 minutes to solve it. A parallel plate capacitor of capacitance 5 microfarad is connected to a battery of EMF 6 volts. The separation between the plates is 2 mm. Find the charge on the positive plate. Find the electric field between the plates. A dielectric slab of thickness 1 mm and dielectric constant 5 is now inserted in the gap to occupy the lower half. Find the capacitance of the new combination. How much charge has flown through the battery when the slab is inserted? Remember, it remains connected to the battery. So I'll give you 2 minutes to solve it. Yes, I think I have answers. Tell me.
First is 30 microcoulomb.
First is find the charge on the positive plate, the pink question, and the charge on the positive plate is Q is equal to C into V, and the answer is 30 microcoulomb. Everyone got this answer? Yes or no?
Yes, sir.
Next is find the electric field between the capacitor plates. You have to find out the value of electric field. What is the answer?
15 by A epsilon naught.
A is not given. The voltage is given. The distance between the plates is given. You cannot find out the electric field. Sad day. It's a sad day in the history of India and your thing. Anyways, electric field will be voltage potential difference divided by the distance. So it will be 6 volt 6 volt divided by 2 mm. I don't know what all of you are doing. That is the answer for the electric field. Anyways, I will not comment much on it. If you don't remember electric field beta, please go back. Please go back. Please go back. Please go back. To find out the electric field between the capacitor plates, note down it. If you don't remember it, note down it. To find out the electric field between the capacitor plates, it is the potential difference divided by the distance between the plates. Write it down. Write it down in bold, in bold, in bold. Write it down it in bold so that you don't remember it, so that you don't forget it. Anyways, that was the answer for the second part. Now comes the third part. I hope we will have better results in this one. A dielectric slab of thickness 1 mm and a dielectric constant K is inserted between the gap to cover the lower half of it. What is the capacitance of the new combination? Do we have the answer for this one? Yes or no? Everyone is chilling out. What question is this? Anyone knows the answer? No one knows the answer. And this is a type of question we have never seen. If I would have drawn the diagram
25 by 3, sir.
the diagram looks like this, and the lower half is filled with a dielectric, whose dielectric constant is 5. Dielectric constant is 5 and thickness is 1 mm. So which formula should I use here? C dash by C will be equal to D upon D minus T plus T by K. So C dash by C would be equal to distance between the plates is 2 divided by 2 minus 1 is 1 plus 1 by 5. So what will I get?
C dash equals to 25 by 3.
25 by 3. Pakka?
Pakka, sir.
Okay, good. So C dash will be equal to 25 by 3 microcoulombs. Then we come to the last part of this question. What is the charge that has flown through the battery after the slab is inserted? Can you find this out?
120, sir.
How did you get it? You have to find out the new charge. New charge Q dash is the new capacitance 25 by 3 into voltage is same into 6. 25 by 3 into 6 is how much? 50 microcoulomb. Yes or no? Yes or no? So how much charge has flown through the battery? 50 minus 30, and the answer is 20 microcoulombs have flown through the battery. 20 microcoulombs has flown through the battery. Do we understand this? Yes or no?
Yes, sir.
Anyone got the answers for this one? Anyone? Please raise your hand that I got the answer, all the parts. No one got it. So what you will do is I will give you 5 minutes. Everyone will now do this question on your own without looking at the board. Once you are done, your same question can come in the examination hall. So now you will have 5 minutes of your me time. In that me time, I'll give you one more question after this. That question everyone has to do. So in that me time that you are getting, you will have to solve this question on your own. If anyone gets any doubt, please ask me. Everyone understands how this question was done? Yes or no?
Yes, sir.
Yes. Now 5 minutes of me time for everyone. Everyone will do this question on their own. Once you are done, without looking at the board, you have done this question on your own, then we will move ahead. Is it clear to everyone?
Yes, sir.
5 minutes you have. If you can do it before 5 minutes, please tell me. So here comes this question. All of you should be able to do this. Again, this is from your favorite book. Figure something shows two identical parallel plate capacitors C and C connected to a battery through the switch S. Now this will check everything from the first class of capacitance till the last class of capacitance, because this is the last class of capacitance. Fill the first class till the last class. It's connected to a battery of switch S. Initially the switch is closed. so that both the capacitors are completely charged. The switch is now opened, and the free space between the plates of the capacitors, both the capacitors, remember, is filled with a dielectric of dielectric constant K. Find the ratio of initial total energies. Remember, find the ratio of, find the ratio of initial total energy to the final total energy. Take a deep breath. Open your eyes and solve this question. Aram say I'll give you 5 full minutes. Enough time to solve this question. 5 full minutes. The time starts now. Take it as a challenge. Take it as a question that has come in the examination hall and now is your exam. And if you can do this, you will be able to clear the exam. If you don't do it, well, don't worry. There is next question coming up. 1:36 is the answer I have got. And the answer is 3:5. Anyways, there are funny ways to do things. And what you had to do was just remember this, which I asked you just before the class. That is all that you need to do. The only problem with you is I have always felt that you don't listen to me. And I hope that you will listen to me someday. And I hope that day comes before 24th of January. Because if it is after that, then we are looking at the second attempt. Anyways, let me now solve this question. In the first case, at least you tried. So trial is important. But the problem with you is you don't, as I always keep on telling you, beta, you are just xeroxing everything on the book and doing nothing. Nothing of that xerox.
Sir, 1:9.
3:5 was the answer that I showed you. In first case, let me call that case as blue case. The energy in the capacitors, the first capacitor, let me call the energy as U1. The first capacitor will have energy half CV square. Yes or no?
Yes, sir.
The second capacitor would have energy half CV square. You should have taken 5 minutes to write this. No? No. In the second case, my dear friends, I am explaining and solving it, and I'll do it in less than 30 seconds. In second case, the energy in the first capacitor is connected to the battery, half CV square. Connected to the battery it is. Energy becomes U times K, K times U. I just showed you the formula. I've given you every damn thing in the universe. Still, I don't know what everyone is doing. Anyways, so half into 3C. So 3CV square. And when on the second capacitor, it is isolated, its charge remains constant. On the first capacitor, voltage remains constant. On the second capacitor, charge remains constant. On the first capacitor, voltage remains constant. On the second capacitor, charge remains constant. U2. And when the charge remains constant, energy becomes 1 by K. We have given the formula, I have given you every damn thing, but still, you end up doing all sorts of funny things in life. So the answer in the next case is half into CV square by 3. That's it, my dear friends. You just have to add both and find the ratios. Add this, find the final, find the total energy. Add this, find the total energy, and divide. That was all you had to do. And it should not have taken more than 30 or 40 or maybe 1 minute. I don't know what you were doing. So again, I insist, beta. What do I insist? What do I insist? Again, I insist that please, please, for God's sake, for heaven's sake, please remember what has been told to you in the class, because the same things are going to come in the exam, beta. You don't seem to recollect them. The only reason I can understand is because you're not trying to understand things, you're just trying to copy things down in the board. This question should have been done very simply, very quickly, just by understanding what we had done. Do we understand this now?
Yes,
How
sir.
simple was this question? Yes or no? Do we understand this?
Yes, sir.
And now try to understand what you were doing. Probably you were finding out the charge and the energy. You don't have to do it because I know what type of questions are going to come, and that is why I've given you all those things beforehand. That is the reason I have given you so much of notes. I don't know whether you have made the notes or not. Someone was asking me to send you the notes. I'll send it on your Telegram group. Even if you have not made any damn note in the entire life, I will send you all the class notes. But will that help? That is the question that you have to ask yourself. And I hope that whatever you have written, you have understood it and written. With this, we come to an end of this whew, big part of your course. Electrostatics is gone. And now we are going to move into electric current. More than half of the electric current we have already done. So whatever is left, we are going to do it. And by the end of this month, in the new year, positively, we will be starting with your magnetic field, which is the end of the course for you. Beginning of the end of the course. And we'll try to wrap it up as soon as possible. That's it from my side. I hope you have understood what we have done in today's class. And from now onwards, please do not do any question of capacitance, because now we have to move on to electric current. So please solve questions of electric current and electric current only from today. That's my advice. Please listen to me and please try to understand things rather than just xeroxing them out, because xeroxing will not help. I had given you the notes, but you could not xerox and show it to me how that xerox was important. So please remember those questions. I try to give you examples of everything that I give you, every formula that I give you. I give you an example how it is to be used. This I did not give because I thought, okay, I'll check whether you remember it or not. And as usual, I have not been disappointed because I knew that you will not remember it. And that has been proved true. But that is a loss for me because I can't make you remember that. That's a shortcoming on my part. That is what I understand. Anyways, I'll try to remove that in the next class. I hope we be more attentive, and this is the most difficult question that can come in your JEE main. I can assure you that that is the most difficult one that can come. So I have covered everything that was possible. Take care, and I'll see you tomorrow. And we will start with electric current. Bye bye. God bless all of you.
Sir.